All right, so we're going to be using these same four matrices for all of the ones that we do. And all of the ones that we're multiplying today are all 2 by 2s, so they're going to be the same size, which means we can multiply. Tomorrow we'll talk about what the actual rule is on how we know when we can multiply. So what I want to do first is I'm multiplying A times B, so I'm actually going to write them next to each other. And the order does matter when you're multiplying matrices, so you do want to write A first, and then times B. Okay, so we want to go ahead and set that up first. And this is not as easy as the adding and subtracting is, but it's not extremely difficult either. It's just a little bit of a process that we have to do. So when we multiply matrices, we're multiplying the rows in the first matrix by a column in the second matrix. Okay, so you're multiplying a row by a column. And I have this little way to set it up that will hopefully help. I like to use my fingers to help me keep straight when I'm ready, so I'm also doing it through a board. I'm going to need to do it on the computer for the video, but I'm going to do it up here on the board as well. So what I like to do first is I label the rows in the first matrix. How many rows does this first matrix have? 2. So I'm going to label them on the outside, row 1 and row 2, like that. Okay. So again, row 1 and row 2. And then I'm going to multiply. I'm going to label the columns in the second matrix, column 1 and column 2. And this is just like to help me keep organized what I'm doing as I go through the process. So we are going to start with row 1 and column 1. Okay, so over here to the side, I always put row 1, column 1. And again, that just helps me keep track of what it is that I'm multiplying. Is everybody ready? So we're going to start with the first term in the first row, so 2. Try to do a different color. And we're going to multiply it by 4. What is 2 times 4? 8. Okay, so I'm going to write that down. But we have a second number in the first row and we have a second number in the first column. So I'm going to multiply those 2 as well. So I'm going to multiply the 3 times the 6. What's 3 times 6? 18. Okay, so I'm going to put plus 18 here. I'm going to show you what I mean by I use my fingers. When I start this, especially when you have your paper right there, I multiply these. Okay, 4 times 2, that's where we got the 8 from. And then I'm going to go across with my left hand. I'm going to go down with my right hand, and I'm going to multiply again. 6 times 3, that's where we got the 18. Okay, so we multiply, we go across and down, then we multiply. If there were more terms, we would keep going. Okay, and then we just add these 2 together. What is 8 plus 18? 26. So what I'm going to do is in my answer, in row 1, column 1, I'm going to put 26, okay, because that's what I got from multiplying those numbers. Everybody okay with that? Now we're going to multiply that same row, row 1, by the second column. Okay, so we're going to go row 1, column 2 this time. And hold on just a second. I'm going to looking at this column now. So this time we're going to multiply the first number 2 by the first number 3. 2 times 3 is 6. And then we do the second number, 3 times 0. is 0. So again, using my fingers to help me keep straight what I'm doing. First row, second column, we multiply. Then we go across and down and we multiply again. And then I just add those together to give me 6. And in my answer, in row 1, column 2, I'm going to put 6. Does that make a little bit of sense? Sort of, kind of? Okay. So we have multiplied that first row by each column in the second matrix, so we're done with it. We're going to now move to row 2. And we're going to basically repeat the same process. We're going to go row 2, column 1, and then row 2, column 2. Okay, so if I start here again, I like to use my fingers to help keep straight what I'm doing. Starting in row 2, column 1, the first number in each, we're going to multiply. Okay, so multiply here, 4 times 2, that gives me 8. And then we're going to go across and down, and we're going to multiply again. 6 times 1 gives me 6. Show up here too. Yeah. Row 2, column 1 is what I'm working on right now. And again, 2 times 4 gave me 8. And then 1 times 6 gives me 6. And if I add 8 and 6, I get 14. So that's going to go in row 2, column 1. And then we just repeat the process, row 2, column 2. First term in each, we multiply. 2 times 3 is 6. And then we're going to go across and down, and we're going to multiply again. 1 times 0 is 0. Again, row 2, column 1, we multiply the 2 times the 3, that gives me 6, and then 1 times 0 gives me 0. And so in row 2, column 1, I get 6. So that is going to be the answer. And again, you don't have to do all of that labeling. I just feel like it helps kind of stay organized with what you're doing. But basically, you take each row in the first matrix, you multiply it by each column in the second matrix. Once you're done with that, then you move to row 2, and you repeat the process. Make a little bit of sense, kind of, sort of? Okay. Again, these are the same 4 matrices. I just have them written again because I can see them. So go ahead and set this one up. We're going to multiply C times D. You want to first write them next to each other, because if you switch the order, then it does change the answer. So I'm going to write C times D. And then again, I like to label the number of rows in the first matrix and the number of columns in the second matrix. So let's start with row 1, column 1. I want you to try that process. Okay. Again, you can use your fingers as first term in each. Multiply. And then you're going to go across and down. You're going to multiply again, and you're going to add those together. And that gives you the value for row 1, column 1. row. Mm-hmm. By column. Yep. Uh-huh. All right, so again, we're starting with the first row. We're going to multiply the first number in the first row by the first number in this first column, and 1 times 0 gives me 0. Then we do the second number in each. We go across, so -6, and we go down, times 0 is going to give me another 0. So in my answer, in row 1, column 1, we're going to put 0. Everybody okay with that? Now do row 1, column 2. Oh. Start with the first number in the first matrix in row 1, and then the first number in the second matrix, column 2, was 0 times 0. 0, okay. And then the second number, the second number in the first row times the second number in the second column, -6 times 1 is going to be, and so 0 plus -6 is going to give me -6 in row 1, column 2 in my answer. Okay, so again, I like to use my fingers. So we have 2 rows, we have 2 columns. That kind of tells me what my answer is going to look like. Row 1, column 1, row 1, column 2. And then we're going to go row 2, column 1, and row 2, column 2. So starting row 1, we multiply. We go across and down, and we multiply again. And that's how we got the 0. Row 1, column 2, we multiply. And then across and down, and multiply again. And that's how we got that -6. So in my answer, I'm going to have 2 rows and 2 columns. And I can put my numbers where they belong. Again, to me, the labeling helps me keep everything organized. If you don't feel like you need to label, then you don't have to label. Now repeat the process. Go ahead and do row 2 by column 1 and column 2. And let's see what we get. Remember, you go across and down. Cross and down. Cross with your left, down with your right. If you're using your fingers to help keep things straight. So row 2, column 1, the first numbers, I'm going to multiply. And I get 5 times 1 is 5. And then I go across and down, and 1 times 0 is 0. So we get 5 there. And then we're going to do the same thing with row 1, column, row 2, column 2, after I erase all my stuff. So row 2, column 2, 5 times 0 is 5. And then 1 times 1 going across and down is 1, and 5 plus 1 is 6. No, I did something. 5 times 0 is not 5, is it? Let me try. I was like, that's not right. Try that one more time. 0 plus 1 is 1. Okay. So that would be my answer. Now, do you notice in that one that your answer is the same thing as C? Does everybody notice that? So that D, anytime you have a matrix where you have your main diagonal starting in the upper left corner, going to the bottom right is 1, and everything else is 0, that's what we call an identity matrix. That's like multiplying by 1. Okay. If it were if it were 3 by 3, which we'll get into bigger matrices tomorrow, my identity matrix would look like this. That main diagonal would be ones. Everything else would be 0. That's, again, an identity matrix. Whatever you multiply it by, it's going to be the same thing. Not that you have to remember that, because you can go through the process and get the same answer. Is everybody okay? All right. I want you to try this one. Try B times C. Do the whole thing by yourself. Again, it's the same 4 matrices, so you don't have to write them again. Just write B first, then C. Label row 1, row 2, column 1, column 2, and then begin the process. It's across and down. Across with the left, down with the right. All right, so let's start. Row 1, column 1, we're going to multiply 4 times 0, which gives me 0. And then across and down, so 3 times 5 is 15. 0 plus 15 is 15, and that goes in row 1, column 1. Yeah. All right, then we're going to go row 1, column 2. So we're going to multiply 4 times negative 6, which is negative 24. And then we're going to multiply across 3 and down times 1. 3 times 1 is 3. And negative 24 plus 3 is going to give me negative 21. And that goes in row 1, column 2. Then we're going to do row 2. So I'm going to go 6 times 0, which is 0. And then across and down, 0 times 5 is another 0. And 0 plus 0 is 0. And that goes row 2, column 1. And then we can do the last piece. Row 2, the first term, 6 times column 2, the first term, negative 6. That's negative 36. Then we go across, 0 times 1 is 0. And that's going to give me negative 36 for row 2, column 2. Everybody okay with that? Again, all we're doing today is 2 by 2s multiplied by a 2 by 2, which is going to give us a 2 by 2. Tomorrow we'll talk about how to multiply different matrices that are different sizes and how to tell when we can multiply and when we can't. I got one more for you. Is everybody ready? Anybody have any questions on this one? Okay. What I want you to do is C squared. And here's the thing. It doesn't mean just take C and square every number in it. It means you've got to do C times C. It will not be the same as just going through and squaring every number. So go ahead and write C next to itself 2 times. And then start your process. Okay. You can't just go through and square all your numbers. It doesn't work that way. There is no shortcut for that. You're just going to do C by itself. You can label your rows and your columns. And then set it up, row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. I'll give you some time to do that. Again, I find it helpful to use my fingers so I don't lose track of what I'm doing. Start at row 1, column 1, multiply. You go across and down, you multiply. You add those results together. All right, I'm going to start in the beginning. Row 1, column 1, 0 times 0 is 0. Across and down, negative 6 times 5 is negative 30. 0 plus negative 30 is negative 30. Then I'm going to do row 1, column 2. So 0 times negative 6 is 0. Across, negative 6, and down times 1 is negative 6. So in my first row, I get negative 30 and negative 6. Does everybody agree with that? Okay. All right, then we're going to go row 2. First terms, column 1, 5 times 0 is 0. Across and down, 1 times 5 is 5. That's going to give me 5. And then row 2, first term, 5 times column 2, first term, negative 6. It's negative 30. We go across and down. 1 times 1 is 1. And negative 30 plus 1 is negative 29. So we get negative 30, negative 6, 5, and negative 29. Everybody okay with that? Anybody have any questions? Kind of get the multiplying, row by column, across and down.